let x be Poisson variate such that p of x is equal to 1 equal to 2 into p of x equal to 2. Calculate the following. Number 1, p of x equal to 0 and p of x greater than 0.5. Second one, p of 3 by 2 less than x less than or equal to 7 by 2. Third one, e of 3 by 2 x plus 1. Fourth one, variance of 1 by 2 x minus 1. So this is the problem. So x is Poisson variable. That means x represents the Poisson distributions. Okay, so we know that the probability mass function of Poisson distribution is p of x is equal to e power minus lambda power x by x factorial, where x is equal to 0, 1, 2, etc. So this is the probability mass function of Poisson distribution. Okay, so here from this, in the Poisson distribution, mean and variance, the mean and variance both are equal to lambda. So in the Poisson distribution, mean and variance are equal to lambda. Okay, so by using this probability mass function, I am going to find out p of x equal to 0. But to find out the value, I want to find out lambda. For that, they are given p of x is equal to 1 is equal to 2 into p of x is equal to 2. So this is given. Okay, so what is p of x equal to 1? Substitute p of x is equal to 1 here, so that it is e power minus lambda power 1, because x is equal to 1, lambda power 1 by 1 factorial is equal to 2 into, put x equal to 2, e power minus lambda power 2 by 2 factorial. But 2 factorial is 2, 2 can be cancelled, and e power minus lambda cancel, so which implies that lambda equal to lambda square. Therefore, lambda square minus lambda equal to 0. Take lambda outside, so lambda into lambda minus 1 equal to 0, which implies that lambda is equal to 0 and lambda is equal to 1. But lambda equal to 0 is not possible. Therefore, the value of lambda is 1. Okay, so next I am going to find out p of x is equal to 0. Okay, so now in the Poisson distribution, x is equal to 0 means e power minus lambda power 0 by 0 factorial. But already we found lambda value is 1. Therefore, e power minus 1, lambda power 0, anything power 0 and 0 factorial, the value is 1. So that p of x equal to 0 is e power minus 1. So the first question over. Second one, we have to find out p of x is greater than 0.5. So next I am going to find out p of x is equal to p of x greater than 0.5. Okay, to find this, in the Poisson distribution, the values of x are integers, 0, 1, 2, etc. So here x is greater than 0.5. 0.5 is non-integer. So greater than 0.5 means it's obviously x is greater than or equal to 1. So x greater than or equal to 1 can be written as 1 minus p of x less than 1. Okay, so in the range less than 1 is only 0. Therefore, it is 1 minus p of x is equal to 0. But already we found p of x equal to 0. It is e power minus 1. Therefore, this is 1 minus e power minus 1. So this is the value for p of x is greater than 0.5. So this is also over. Okay, so next I am going to find out p of 3 by 2 less than x less than or equal to 7 by 2. So this is I am going to find out. Okay, what is the range here? So consider the line, my plus infinity, here minus infinity, but here the range starts from 0. In the Poisson distribution, range starts from 0, so that you don't take, only start from 0. Okay, here 3 by 2 is possibly here and 7 by 2 is here. Okay, so in between, so 3 by 2 is 1.5, 7 by 2 is 3.5. So the next value of 1.5 is 2. So P of x is equal to 2, plus next value of 2 is 3. P of x is equal to 3. So next value is 4, but it is out of the range. So that only in between, only the value 2 and 3. Okay, so in the Poisson distribution, already this is the Poisson distribution, put x equal to 2. So that e power minus lambda, lambda power 2 by 2 factorial. E power minus lambda, lambda power 2 by 2 factorial. Plus for 3 is e power minus lambda, lambda power 3 by 3 factorial. But already we found lambda is 1. So that it is e power minus 1, 1 square by 2. Plus e power minus 1, 1 cube by 3 factorial is 6. So take e power minus 1 outside. So this is 1 by 2 plus 1 by 6. So I am going to simplify, take LCM 6. So this is 3 plus 1. 3 plus 1 is 4. So that the final answer is 2 by 3 into e power minus 1. So this is the value for the range P of 3 by 2 less than x less than or equal to 7 by 2. The value is 2 by 3 into e power minus 1. So next I am going to find out e of 3 by 2 x plus 1. But the formula is e of ax plus b. B is a constant, a also constant. So but a is multiple with one variable x. So this can be written as a into e of x plus 1. Sorry, a into e of x plus e of b is b. Okay, so here similarly this can be written as 3 by 2 into e of x plus e of 1. E of 1 is 1. Okay, but e of x is mean. Mean of the Poisson distribution is always lambda, but already we found lambda value is 1. Therefore e of x value is 1. So that 3 by 2 into 1 plus 1. So finally 2 into 1, so 5 by 2. So this is the 5 by 2 is the value. E of 3 by 2x plus 1 value is 5 by 2. Next we want to find out variance of 1 by 2x minus 1. So the formula is variance of ax plus or minus b equal to a square variance of x. The constant becomes 0. So the coefficient of x you have to write a square variance of x. So by using the same formula, variance of ax plus b, here a is 1 by 2. So a square variance of x. So 1 by 2 the whole square is 1 by 4. Variance of x in the Poisson distribution, mean and variance are equal to lambda, but lambda is equal to 1. So that variance is also 1. So 1 by 4 into 1, 1 by 4. So the answer is 1 by 4.